for today. So for today, so which you're going to be discussing what? So let us understand for today. Let us understand for today. So what is DevOps? So whoever all knows DevOps, please let me know in the chat box quickly, please. Whoever all knows, whoever all understand what is DevOps? Do you know anybody have an idea about DevOps? What is DevOps? So do you have an idea about what is DevOps? Please can you reply in the chat box quickly? Can you reply? Anybody can you reply in the chat box quickly, please? Okay, fine. So today we're going to be discussing about what is DevOps. What is DevOps? And let us understand today for what is Docker. So by Docker container, by using Docker container, how we are deploying applications. How we are going to be deploying applications. Got it very clearly. So this is an exact agenda for today's session. Okay, please tell me. So let me introduce before starting the session. Let me introduce myself. So my name is Lakshmi Rao. I have totally 12 years of experience in IT. So my career start as a Java programmer, and from the last 5 years onwards, I'm working as a senior DevOps engineer as well as AWS. This is exactly my profile. This is exactly my profile, guys. Please. Fine. So let us understand first. Let us understand first what is DevOps and what are the purpose of DevOps. And so how exactly we're going to be implementing DevOps process. Let us understand first. Then we'll see. So how exactly we are working, what is the Docker and how exactly we're going to be working with the Docker. Let us experience today in this workshop. This is an exactly for today's session. Okay. So before starting this session, so let us understand. So I think everybody know about these 4 questions, and I want to clarify with you these 4 questions, guys, please. So what is an application? What is the server? What is the time to market? What is SDLC? What is SDLC? So we should be clarified these 4 questions, then we will start what is DevOps, please. So what is an application? Anybody help me? Do you have an idea about application? Anybody help me in the chat box quickly? What is an application? Application is nothing but what? Website. Like Redbus, Abibus, Redbus, Abibus, or else Flipkart. What I mean. So these are all we calling as an applications. Clear? What is an application? The working software which is written any programming language we call as an application, please. The working software which is written any programming language like Java, .NET, Python, we calling as an application. That application we're going to be deploying onto the servers. We're going to be deploying onto the servers. We're going to be deploying onto the servers, and from there itself we're going to be accessing over an internet as a website. Clear, all of you, please? Understood? Clear? So what is an application? Anybody help me? The working software which is written any programming language. The working software The working software which is written in any programming language we call as an application. That application we're going to be deploying onto the servers. That application we're going to be deploying onto the servers. Then there itself we're going to be accessing over an internet as a website. Clear all of you? This is an exactly please what application server. And what about third one, guys, please? Time to market. What are the time to market? Anybody help me? So usually what will happen from dev environment to production environment? From dev environment to production environment, please. Dev environment to production environment. From dev environment to production environment, we are going to be delivering. We are going to be delivering working software from dev environment to our production service. Usually what will happen? Our application we are developing in where? Dev environment. From dev environment to production environment we are going to be delivering. So while delivering from dev environment to production servers, production environment, we need to deliver within a shortest time with the high quality with low cost is nothing but a time to market. Listen very carefully, I'm going to be repeat one more time. So from development environment to production environment, if you are moving application as a software within a shortest time with the high quality with low cost is nothing but a time to market. Clear all of you? I hope you understood what is an application, what is the server, and what is the time to market also, please. And let us discuss about SDLC. What is SDLC, please? Anybody? Anybody, please? Please, I'm waiting for you, please. Speaking to someone else. You can wait or call again later. Clear all of you, please. Please, what is SDLC? Please, anybody help me? SDLC in the sense of what? Software development lifecycle. SDLC in the sense of what? But please tell me, please. So what is SDLC, please? What is SDLC, please? Software development lifecycle. Yeah. What is exactly, please? Software development lifecycle. Yes. So in SDLC we have several stages, several phases like analysis, design, implementation, testing, deploy, and maintenance. So we have several stages and several phases. So by following these stages or phases, what I may be by following the stages or phases, so we can able to deliver a robust kind of applications. I'm going to be repeat exactly, please. So by helping of this SDLC, we can able to deliver the working software as an application. The working software as an application. For example, if you want to build an application, if you want to build for example, a kind of a house, for example. So can we able to build a house overnight, please? Is it possible? Can able to build a house? Can able to construct the house overnight? No, it is not possible. Am I right? Yes. So, but what I'm trying to tell you, please, if you want to construct the house, what we required? We need to information. We need to gather the information first. Then we need to require a plan, and we're going to be start with basement, beams, walls, slope, plumbing, electrical, plastering, paints, and German. And so many stages we have or not while you building a house or construct the house, please. The same way, to build a red bus kind of applications, okay, we can't able to complete within overnight. So we need to follow some stages: analysis, design, implementation, testing, deploy, and maintenance. We need to follow these are all the stages and phases. Then we calling as a, by helping of these phases or stages, we can able to deliver a working software as a website. Clear? Let us understand what is the analysis, please. First, we need to gather the information. What kind of business this? What kind of business this? Okay. And after analysis, we require a design. Is nothing but a plan. Is nothing but what? Plan. Is nothing but what? Plan, please. Is nothing but what? Is nothing but what? Plan. According to the plan, our developers will implement. Our developers will implement the software by using Java, .NET, any other programming languages. Then after developing a software, whether it is working or not, we're going to be verifying the testers. So validating with the testers. After executing test cases, if there is no error, if there is no bugs, we're going to be deploying onto the production service. From there itself, we can able to access our internet as a website. Then that's it. No, whether it is an application is properly working or not, we need to monitor and maintenance. So by following the stages or phases, we can able to deploy and maintenance our application very perfectly on our production service. Got it very clearly what is SDLC? Got it very clearly SDLC. Okay, let us start DevOps, please. What is DevOps, please? A deep in the sense of what? Development. OPS in the sense of what, please? Operation. The combination of software plus operation we call as DevOps. The combination of software development plus operation we call as a DevOps, please. As a DevOps engineer, sorry. As a DevOps engineer, our roles and responsibilities start from dev environment, ends with operation. As a DevOps engineer, our roles and responsibilities start from dev environment, ends with operations, please. That means, so we are part of coding, build, test, release, deploy, operation, and monitoring. But to be frankly, we are not developers, we are not testers. Just we are implementing a DevOps process on SDLC. On SDLC. Got it very clearly? Got it very clearly what is DevOps? Dev in the sense of development, OPS in the sense of operation. The combination of development plus operation. The combination of development plus operation we call as DevOps. That means our roles and responsibilities start from dev environment, ends with operation. Ends with operations. We are part of coding, build, test, release, deploy, operation, monitoring. To be frankly, we are not developers, we are not testers. Just we are implementing a DevOps process on SDLC. Got it very clearly what is DevOps? So as a DevOps engineer, we are going to be implementing a DevOps process in SDLC. As a DevOps engineer, we are going to be implementing DevOps process on SDLC. While implementing DevOps process on SDLC, we need to mitigate. While we implementing DevOps process in SDLC, we need to follow these mitigations. We need to follow these two rules. What are the first rule, please? Time to market, add business value. Time to market, add business value, please. So the time to market in the sense of what? Anybody help me? Which are already discussed. So which aims to shorten the software development life cycle and provides and continues with the highest quality with lowest cost. Tell me. So while we delivering working software from dev environment to operations, we need to deliver the working software within a shorter time with the high quality with low cost is nothing but a DevOps. and we are going to be implement this DevOps process with an automated way, with the transparent way, with an automated way, with the transparent way. This is an exactly DevOps. Got it very clearly. But what are all the DevOps pre features, guys? Please, by using DevOps, what kind of features we can able to get? So fastly we can able to deliver, and frequently we can able to deliver. That means what? From dev environment to operation, from dev environment to production environment, we can able to deliver our working software very fastly and very frequently by using DevOps. And we can able to improve a number of development deployments. We can improve a number of times deployments. We can able to increase the highest quality. We can able to produce highest quality software and low cost, with low cost. While we're delivering working software from dev environment to production environment, we can able to spending very low cost with low failure rate also. So these are all the features we have in a DevOps. Got it very clearly, all of you, please? Understood? Clear. So what exactly is and responsibility? Being as a DevOps engineer, our roles and responsibility is replacing with a complex pipeline with a transparent pipeline. That is exactly our prior goal. So as a DevOps engineer, our roles and responsibility is replacing with a complex pipeline with a transparent pipeline. Let us understand what are the complex pipeline, what are the transparent pipeline, what are the difference between these two. Let us understand right now. So the SDLC process, we are calling as a complex pipeline. Why we calling as a complex pipeline as SDLC? Because of from analysis to design, design to implementation, implement to testing, testing to deploy, deploy to maintenance, it will implement a manual process. It is a manual interaction process, and if you got any problem, it is very difficult to identify, and it is very difficult to resolve the issue. Got it very clearly? That's what we're calling as a complex pipeline. Okay, for your understanding, I'm going to be discussed with a layman example. So for example, we have water pipeline. Okay, in the water pipeline, somewhere else blocked, somewhere else blocked, somewhere else block, somewhere else block. Got it very clearly? In the water pipeline, somewhere else blocked. So can you able to identify immediately? Can able to find immediately, please? Is it possible? Where exactly the block in the pipeline? Very difficult or not? Because of it is a complex pipeline. Because of it is what exactly, please? Complex pipeline. So it is very difficult because of it is not easy. It is a manual process. Fine. But what exactly our job, please? So we're going to be replaced with what? A transparent DevOps process. It is an exactly an automated. It is an exactly transparent way. So if we are going to be implement DevOps process and SDLC, everything will be visualized, everything will be transparent, everything will be automated. So while we're delivering working software from dev environment to production environment, if any issue occur, any problem occur, immediately we can able to identify, we can able to give the solution as soon as possible. Because of it, everything is transparent. So look at here, please. It is a water pipeline. Is there any block in the pipeline? Can able to identify immediately or not? Why? Because of it is a transparent. The same concept here also, please. So DevOps is a transparent and automated process on SDLC. Got it very clearly? So what exactly job, guys, please? We are going to be replacing. We are going to be replacing, please. We are going to be replacing our DevOps process. We are going to be replaced with a complex pipeline with a transparent pipeline, please. The transparent pipeline look like this, please. The DevOps transparent pipeline look like this, please. For implementing this DevOps transparent pipeline, we need to follow these all stages. What is the first one, please? Plan, coding, integration, testing, release, deploy, and operations. Clear all of you, please? Understood very clearly. So we are not part of planning, guys, please. We are part of coding, integration, testing, release, deploy, operation. As a DevOps engineer, our roles and responsibilities start from dev environment, ends with operation. But to be frankly, we are not developers, we are not testers. Just we are implementing DevOps process and SDLC from dev environment to production environment. Clear? So let us understand stage by stage what exactly our roles and responsibilities. Let us understand, guys, please. So in dev environment, usually developers writing a code. That code is going to be maintaining by the DevOps engineer. What I said, writing is responsible by the developer, or maintaining a source code is responsible by the DevOps engineer in a source code repository, in a version wide, in a branch wise, in a model wise. Got it? What exactly are roles and responsibility in a dev environment? As a DevOps engineer, we are maintaining a source code in a repositories in a version wide. That's it. But how many developers are writing a code? Please tell me. How many developers are writing a code? Anybody help me? N number of, please. N number of developers writing a code. N number of developers. N number of developers writing a code. All developer source code. All developer source code. We need to integrate continuously or not? Tell me. We need to integrate all developer source code continuously. Got it very clearly by helping of CSR. After integrating all developer source code, we need to execute our test cases, which is written by the testers. Just we are integrating test cases in this flow, and automatically test cases will be executed. And if you got an error, any bug, it will automatically redirect back to the developer. Developer has to fix the issue, again integration, again test. This loop will be repeated. This loop will be repeated until zero errors, until zero bugs, until zero errors, until zero bugs. Guys, please very clearly, until zero errors, until zero bugs. So if there is no bugs, if there is no error, the working software as an application without any error, without any bug, we're gonna be maintaining under release is nothing but a halt. On a particular schedule time, on a particular maintenance window, we're gonna be deploying onto the production servers is nothing but a live. Is nothing but a live. Please, after successfully deploying our applications on production environment, we can able to access over an internet as a website. Clear, all of you? Understood very clearly. That's it. So whether it is an application is working or not, we are gonna be maintain and monitoring is nothing but a operation. Got it very clearly. As a DevOps engineer, our roles and responsibilities start from dev environment, ends with operations. We are part of coding, integration, testing, release, deploy. But to be frankly, we are not developers. We are not testers. Just we are implementing an automated, transparent DevOps pipeline from dev environment to operation. We are take out the source code from the developers, and we're gonna be delivering an automated way until production environment is nothing but a DevOps transparent pipeline. Clear, all of you, please? But if you want to implement this DevOps transparent pipeline, if you want to implement a DevOps transparent pipeline, we need to learn some tool stacks. So we're going to be learning Git. Git for what? Source code. So we're going to be handling and maintaining source code on Git report. And we're going to be learning Maven. Maven is a build tool. Maven is a build tool. We can able to execute, we can able to compile, we can able to execute, we can able to build the project by helping of Maven. And we're going to be learning Jenkins. we can able to automate the entire this process by helping of Jenkins. Jenkins is an automation tool. By helping of Jenkins, we can able to automate. So from dev environment to production environment. And we're going to be learning JFrog, sorry. JFrog is nothing but an artifact. And we're going to be are we calling as release is nothing but a JFrog. And we're going to be learning Sonar Cube. Sonar Cube is nothing but what? Code analyzer. So whether the developers are following standards or not, whether the developers are using right functions or not, the Sonar Cube will be analyzed, and it will be statistics gives. It will give reports how accurately a developer is writing a code in a percentage wise. Clear all of you, please. It is nothing but a Sonar Cube. Clear. And we're gonna be use configuration management. What are the configuration management, please? Manual configuration process replaced with an automated process. Clear all of you, please. And it's nothing but what? For example, we have a hundreds of production servers. On each and every server, if you want to change a file or edit a file or installing a software, how difficult manually? How difficult manually? So, is there any on automate process? Yes, we have. We can able to automate this process by helping of configuration management. How? So we can able to create a centralized server, and if you do any action in centralized server or configuration management server, it will reflect on all hundreds of servers. It is nothing but a configuration management. For example, if any change happen, the change will be reflecting onto the hundreds of servers. It is nothing but an automate process or not? Please tell me. Yes. Clear all of you. That means by helping of configuration management, we can able to automate production environment, testing environment, and dev environment. For this, we're going to be learning Ansible and Chef. We're going to be understood what is Ansible, what is Chef. We're going to be learning in depth. Don't worry. And these hundreds of servers, if you want to automate the entire servers, the hundreds of servers, those hundreds of servers, from where we can able to get it? From the AWS cloud. We can able to get the servers from AWS, and we can able to deploy our application automated way with the help of our Ansible and Chef. We can get the infrastructure or servers from the AWS. Those servers we can able to automate by helping of Ansible or Chef. Please got it very clearly. At deploying, this is the place which we discussing. And we're going to be learning Docker and Kubernetes. The Docker is an isolated area. Docker container is an isolated area which is specifically designed for deploying applications only. Clear all of you, please. Those Docker containers we can able to manage or control by the Kubernetes. Guys, please, we can deploy our application Dockers. Those Docker containers we can able to manage or control by the Kubernetes, please. Clear all of you, please. Understood very clearly. Can you reply, guys, please? Anybody? Up to right now, understood very clearly. So which are all tools we're going to be discussing? And we're going to be learning Vagrant, Nagios. Nagios is system monitoring. Elk is what exactly, please? Elk is what exactly, please? Application monitoring. And we're going to be learning Terraform also. So these are all tools. By helping of these are all the tools, we are going to be implementing a Devops transparent pipeline. Devops, a transparent pipeline, guys, please. Devops, transparent pipeline, guys, please. Got it very clearly. So with help of these are all the tools. Git, Maven, Jenkins, JFrog, Sonar Cube, Ansible, Chef, AWS, Docker, Kubernetes, Vagrant, Nagios, Elk. So by helping of these are all the tools, we are going to be implementing a DevOps, a transparent and automated process from dev environment to production environment. I hope we understood very clearly. Okay, then what next, please? What is a Docker? What is a Docker, guys, please? What is a Docker? Docker is what? Docker container. So Docker is a company name. It provides you, please, what? Container. See, got it very clearly. So Docker is nothing but what? A container technology. So by helping of Docker container, we can able to easily deploying our applications, guys, please. Easily we can able to deploy our applications. For example, for our understanding. So in these containers, are we shipping a different kinds of products or not? Dishes, prawns, crabs, a lot of products. The same way, we can able to deploy a different kinds of applications on my, see, both are looking same, guys, please. Okay, so in these containers we can able to deploy a different kinds of application like Java, .NET, Python, but these are all the containers we can able to manage by the ship. Ship is nothing but a Kubernetes, which you're going to be discussed, don't worry, please. Okay, I hope you understood. So Docker container is an isolated area which is specifically deploying applications itself, which is specifically deploying only applications. But what is an isolation? What is the meaning of isolation? Isolation is nothing but a separate. A container looks an isolated area or not with help of four types, 6 places. Please see. If you see any container, it is isolated. It's look isolation or not. Same way. Guys, please understood. Try to understand. So Docker container is an isolated area. That means a separate environment. For example, for our understanding, which I'm sitting this room is separated. This room is isolated with 4 walls, top and ceiling and floor or not, ground, please. This room is an isolated. This room is separate from a house or not, please tell me. The same way container also, please. The container also an isolated, and it is specifically deploying what? For applications. Clear all of you, please? Understood very clearly. Understood, please. But what are the purpose of Docker, please? What is an advantage of Docker, please? Let us understand. For example, I want to deploy Java applications. I want to deploy .NET application. I want to deploy Python application. I want to deploy 3 applications. Tell me, without container technology, so how can you able to deploy, please tell me? Without containers. Without containers, please tell me. Please tell me. Without containers, if you want to deploy, how exactly we can, guys, please? So that means we need to create a separate server, guys, please. We need to create a separate servers. Let us assume it is my server 1, AWS server 1. Okay. On top of it, so we are deploying Java applications, guys, please. Java app. And the same way, listen very carefully. The same way, I'm going to be creating one more server. So I'm going to be creating server 2. In this server, I'm going to be deploying .NET application. In this server 3, I'm going to be deploying Python applications. Clear all of you, please. So totally how many servers we have created, please anybody tell me? How many times we invested, please? How many times we invested, please anybody help me? How many times we invested for deploying these 3 applications, please tell me. All of you please reply. All of you please reply in the chat box quickly. 3 times, am I right? 3 times. We have invested 3 times. But if you are using container technology, what will happen? With the containers, please. With the container, please. These 3 servers required, not required. So it is enough, only one server. One server is enough. On top of the server, we can able to create a containers. I'm going to be creating container 1. In this container 1, I'm going to be deploying Java application. I'm going to be creating container 2. In container 2, I'm going to be deploying .NET application. I'm going to be creating container 3. In this, I'm going to be deploying Python application. So tell me, how many times we invested? Please tell me. How many times? 1 time or 3 times only? How many times we invested? 1 time. That means what? That means what? Is it reducing the cost or not? It is cut down the cost or not, please. And one more important, it is an isolated area. It is a separate environment. That means what? So after getting into the container only, we can able to come to know Java, or else we don't know, please. The Java application or Java will available only inside a container, but not outside. Got it very clearly. This Java application available inside a container, but not on server, please. It is nothing but an isolated area, please. Got this very clearly, all of you. So why we are using containers, please? Because we can able to reduce the cost. And one more thing, very important, the cost will be reduced and performance will be increased, please. The cost is reduced, and one more thing, the performance will be increased. Why? Because please, if you are allocating, for example, 2 GB of RAM, the 2 GB of RAM 100% utilizing by the application. That means the performance will be increased. The cost is reducing, the performance will be increased. Tell me, who don't want this technology? Who don't want this technology? Please tell me. Got it very clearly, all of you. Understood? Clear, understood very clearly. Can you reply? Got it? So instead of deploying our application on servers, and we're going to be deploying onto the containers, guys, please. Got it very clearly. And one more important point, why we are going to be moving into the container technology, let us understand. Okay, if you want to deploy applications, listen very carefully. Okay, if you want to deploy applications, we require a service. We can deploy application on servers, and easily we can able to access over an internet. We can deploy applications on servers, and we can able to access the websites. Okay, business for what? Application for what? Running a business in internet. That application we can able to run on servers. On a physical server we can able to deploy. On a physical server we can able to deploy, or else we can able to deploy our virtual server also. We can deploy we can deploy our applications on physical server or virtual server also, there is no problem. For example, if you are deploying our applications on, if you're deploying our application, if you want to deploy our application is nothing but a website on virtual machines, what will happen? Let us see. For example, we have 8 GB of RAM. This 8 GB of RAM dividing by these 4 VMs. Here is 2 GB, here is 2 GB, here is 2 GB, here is 2 GB. Got it? So how much GB in the VM1, please anybody help me? What are the RAM size, please? What are the RAM size, please anybody? 2 GB. So on top of the 2 GB, okay, our operating system will be occupied 1 GB. Remaining 1 GB will be occupying by the applications. Got it? Here also same, 2 GB here, 1 GB by operating system, 1 GB by application. Here also 2 GB, 1 GB by operating system, 1 GB by application. Here also 2 GB, 1 GB by operating system, 1 GB by application. That means what? So out of 8 GB, 4 GB is occupying by the operating systems, and remaining 4 GB we can able to deploy applications. But if you are using virtualizations, so our VMs and operating system is occupying by CPU, RAM, disk, and moreover each and every operating system is required licensing cost, and moreover for creating a VM admin time is required. Got it very clearly if you're using virtualization. But if you are moving into the container technology, so what will happen? The operating system is not required. Directly we can deploy our application onto the top of the container. So on a same 8 GB RAM, here we can able to deploy only 4 applications. But if you are moving into the container technology, we can deploy 8 applications. 4 applications already deployed. One more 4 application we can able to deploy in this empty space. Same resource, same RAM size, but here we can deploy 4, but here we can deploy 8 applications. So tell me, so who don't want this technology? Got it very clearly. If you don't have operating system, so if we don't have an operating system, the operating system is not occupying RAM and admin time is not required, and moreover license cost also we don't need to pay anything to the operating system, guys, please. That's what by using Docker we can able to reduce the cost, and we can able to increase the performance, and we can able to got it very clearly, we can able to utilize resources properly. I'm going to be repeated why we are going to be using Docker containers, please. Docker is an isolated area which is specifically designed for deploying our applications only. By using Docker we can able to reduce the cost and increase the performance, and moreover operating system is not required. These are all the features of Docker. So shall we explain this practically, please? Can you reply, guys, please? Shall we explain this practically? All of you, please. Shall we explain this practically? So that means what? What I'm going to do that, please? What I'm going to do that, please? I'm going to be creating AWS server. On top of I'm going to be creating a container. That's it for today. So let me create a AWS instance first. Let me create a AWS server. On top of it, I'm going to be installing Docker host machine. What I'm going to be do that, please? I'm going to be repeat this diagram for our understanding. I'm going to be creating a server. I'm going to be creating a server. This is let us assume it is server. Then we calling as a Docker host. Docker host. In this Docker host machine, in this AWS server, in this, I'm going to be creating a containers. It might be Nginx container. It might be I'm going to be creating Tomcat container. I'm going to be creating Jenkins containers, please. Shall we do this practically, please? What are the first step, please? So you need to sign up and sign in AWS account. You need to sign up and sign in AWS first. You know very well. So first, please be sign up and sign in. Please be sign up and sign in. So, so who don't know how to sign up and sign in, please use this Google Drive. In this Google Drive, how to sign up and sign in, I clearly written the document here. I clearly written the document, please. 1 second. So have you received this link, please, all of you? Have you received this link? Please double click. It will be open the Google Drive. It will be open a Google Drive, please. In this Google Drive, you can able to see how to create AWS account. By helping of this document, we can able to sign up. Please use this document. Okay. So I think everybody received this document. Yeah. Yeah. No, Azure also, please. Azure also, please. Yes. Azure, any cloud, but we are going to be using, please. We are going to be using as, please. We are going to be using as, please. One second. Yeah. So I think everybody is receiving in this. So can you reply in the chat box quickly, please? Yeah, fine. So let me sign in, please, first. T8 T2ZX. Let me sign in first. Let me sign in. After successfully sign in, please be create a server. Please be create a server by helping of EC2. By helping of EC2, we can able to create a AWS server. How exactly, please? Launch instance. Ubuntu. I'm going to be choosing Ubuntu Linux machine. I'm going to be choosing Ubuntu machine, please. Select Ubuntu 16. T2 micro. Configure the details. Let us use this options, default options. Storage, yeah, please don't be change anything, only default options on. Let us a tag name called Docker host machine. Docker host. Configure the security. Please use all traffic. So please choose anywhere. And review launch with an existing PEM file, or else we can able to create a new PEM file also. We can able to create a new PEM file. The PEM file name is what? My DS workshop. Is something. You can type anything, guys, please. And with this name, we're going to be downloading the file. So after successfully downloading this file, please click on launch instance. So if you click on launch instance, The server will be created in AWS, not in a laptop. After successfully creating, after successfully running this instance, we can able to getting into this cloud mission. We can able to getting into the cloud mission, please. How exactly we can able to getting into the cloud mission? By helping of any Linux terminal. That is the reason I'm going to be installing Git for Windows. Please download Git. Please download Git. After successfully downloading it, double click, run, next, finish. After successfully installing Git bash, then let us copy this PEM file for our convenience. Copy this PEM file, pasting into the desktop. After pasting into the desktop, and we can able to getting into the cloud machine, please. So is my cloud server is running or not, which you call in Docker host machine. Yeah, let me getting into this mission. How exactly, please? How exactly, please? Select the server, connect, select the server, connect, and copy this SSH connection. Copy this SSH connection. Copy this SSH connection where exactly we have PEM file downloaded, any location in laptop. Just right click, git bash. Just right click, git bash, please, and paste your SSH connection. Paste your SSH connection, please. Paste your SSH connection. Yes, to continue. So are we getting into the cloud mission or not? Yes. Sudo -i, yes. We have successfully switching into the administrator. Please switch it to administrator by helping of sudo -i. Then we can able to execute command call apt-get update. By executing this command, we can able to download default software from internet into the server. After successfully downloading default softwares from internet into the server, then the server is ready for installing any software. Then the server is ready for installing any software. Right now, what kind of software you want to install? Please tell me. What exactly I want to make it? Anybody help me? Docker host. I want to install Docker engine in this instance. How exactly, please? So in the Google, write down, please. Get.docker.com. In the Google, please. Get.docker.com. So please download this shell file by helping of this link. Please download the shell file into the server. So have you successfully downloaded shell file or not? Yes. By executing the shell file, we can able to install Docker. That's it. Please wait. Please wait. Please wait. So the Docker is going to be installing in your AWS server. So please wait one more 10 minutes. The session will be completed within 10 minutes. Please bear with me. Please. So have you successfully installed Docker or not? Yes. Have you successfully installed Docker or not? Yes. So is there any containers? Empty. Is there any containers? empty. There is no containers. Is there any images? So what we gonna be creating? How exactly we can able to create, please? With the help of the image, we can able to create a container. For example, if you go for hub.docker.com, we can able to find any images. For example, I want to find Nginx image, or else if you want to go for Tomcat, yes, Tomcat. If you want to go for Jenkins, yes, Jenkins also, yes. So by helping of these images, we can able to create a content. Yeah, shall we create a one container, please? Anybody? Yeah, shall we create Nginx container, please? Anybody, please? How can I, please? Docker run my container one -d -p 8081:80 Nginx. That's it. With the help of this image, okay, we can able to create a Nginx container. First, the Nginx image will be downloaded into the local register in your lab, in your server. On top of it, the container will be created. See. So have you successfully create a container or not? Yes. But how can able to access this container, please? Anybody help me? How can able to access with help of public IP? With help of public IP, guys, please. Let us copy public IP of the server and pasting into the browser and colon 808. That's it. Is it Nginx container or not? Yes. The same way, I can able to create a Tomcat also. Docker run name my container 2. Second container I'm going to be creating -d -p 8082:8080 Tomcat colon 8.5.37-JRE8. With the help of this image will be downloaded. On top of it, container will be created. How easily we are creating containers, guys, please? How easily we can deploy applications? Easily or not? Yes. So have you successfully created container 2 or not? Please tell me. Anybody? Container 2 has been created or not? But how can able to access our internet? Public IP colon 808. Is this Tomcat application server is ready or not? Yes, it is ready. Then I want to create a Jenkins container. Docker run -name my container 2 -d -p 8083 colon 8080 Jenkins colon 2.60.3. Sorry. Docker run my container 4 my container 3 what -d -p 8084 colon So the point is what you understand by simple command. By executing one command, are we getting a container or not? Are we installing n number of commands, executing a lot of things, lot of process? Nothing. By executing a single command, are we getting a container? On top of it, we deploying our applications or not? Say yes or no in the chat box quickly. Yes. So have you successfully created a container or not? Docker? Yes. The container 3 has been successfully created or not? What are the port number? 8084. See, our Jenkins server is ready or not? Our Jenkins application is ready or not? Please tell me. Sometime it is Ankita. So Ankita, so what I'm trying to tell you, please, some of the free, some of the paid in AWS. Which are all free, which are all not free. In regular sessions, we'll discuss. Don't worry. So by using DevOps, can we able to deploy application very easily or not? Got it very clearly. So in this deployment, we are going to be using Docker containers, guys, please. Got it? How exactly we are deploying our applications easily. In the next container we have created, Tomcat container we have created, and Jenkins container also created, and easily we are accessing over an internet. So if you type here 1 means what? In the next. If you type here 2 means what? Tomcat. If you type here 4 is nothing but what? Jenkins. How easily we are getting a containers and how easily we are deploying our applications. Got it very clear? Understood? Fine. So that's it for today's session. So I hope you understood how we are going to be. What is the DevOps? We understood very clearly. And so how exactly we are handling one real-time scenario we understood in this workshop. What is the Docker we understood. By using Docker container, how exactly we are deploying application. Let us consider Jenkins as a Java application. Jenkins as a Java application. Please be considered. And we can deploy our own application like Java application. Yes, we can. Got it very clearly. Okay, please wait. This is what exactly workstation. Okay. So if you want to continue regular sessions, so the regular session and the regular sessions. So we're going to be discussing 2 courses on complete AWS and DevOps with AWS also. Both. AWS will take around maybe 1 month plus. So DevOps with AWS will take maybe 2 months plus total. For learning these courses, it required Linux basics and shell script. Okay, so these 3 all will covered on the same syllabus and same in a single unit, single course, please. So our regular sessions start on Monday. One second. 8:30 a.m. Okay, please. So every day there's classes. Let me write down. Okay, the sessions are Monday to Saturday. So recordings will be provided. Got it very clearly. So my course content, DevOps with AWS Kit. Go through this. Please use this. This is my Google Drive link. And if you want to talk to our admin, please talk to our admin. Please. How exactly? Please copy paste this link in Google Drive. You can able to see my course content. So what are the content we cover under DevOps and what exactly we cover in AWS? See this from here itself. So by seeing this itself, which are the topics we're going to be covering in the regular sessions, then please be joined. After seeing this content only, please be joined. Please. And so who are all want to create AWS account by following this, please. And so how to create a server for today's session, which I have covered, everything will be there. Please go through this once, all of you. Okay, please. So I'm copy paste one more time in the chat box. Please go through this once. So are you received this Google Drive link for everybody? Have you seen this? Are you received, please, this Google Drive link, everybody? So do you have any questions, please? Do you have any questions? Do you want to talk to me, anybody? Yes, yes, yes. Yeah, please. Any questions, please, in the chat box quickly? Do you want to talk to me or else? Can you reply in the chat box quickly? Six months and more than 6 months. 6 months, guys, please. More than 6 months. After 6 months also you can able to access, but we're saying the duration, no? That's what we namesake we're saying only. Got it? Any questions, please? I'm waiting for a reply. No, no, no. So you want to talk to Manikanta? Please, any questions, please? Is anybody want to talk to me? No questions, please. I'm waiting for you, please. Can you reply in the chat box quickly? Okay, fine. Fine. Thanks. So any questions, please? Do you have any questions or you want to talk to me? Please let me know. We can discuss, or else we'll meet on Monday. Thank you. Thanks for reply. Vadai, Pratap, Reddy, Manikanta, Datta, all of you. Thanks all of you, please, for today's session. Pratap, Reddy, Ramakrishna, Srini, all of you. Okay. Thank you, guys. I hope you understood very clearly for today's session. We'll continue on Monday. Monday at exactly, please. Monday at exactly, please. Monday exactly at please 8:30 a.m. Thank you. Thanks all of you, please. Thanks for it. Nothing. So daily activities that so we can create a containers, a lot of activities, and so data so we are observing Jenkins jobs. So if it is any fail, we need to look at the Jenkins jobs and we need to verify creating Jenkins jobs, Ansible playbook, writing a playbooks by using Ansible, and for deploying our applications on production environment, a lot of things. Yes. Fine. Thanks, buddy. So we'll meet on tomorrow. We'll meet on Monday. Thank you. We'll meet on Monday at 8:30 a.m. Thank you. Thanks a lot.